external programmer, they can upload the program inside of the microcontroller, and here in the form of ROM, here is EEPROM. In the form of ROM, here is EEPROM, electrical erasable read only memory. Means when I will upload the second program, first program will be automatically delete. And in the form of RAM, here is SRAM, static random access memory. And here on the pin number 13, digital pin number 13, there is a inbuilt LED on the pin number 13. On the pin number 13, there is an inbuilt LED. And here is, you can see something red color. This one is reset button. This one here you can see, this one is the reset button. Actually what happened, the use of this reset button is to reset the program. Suppose that any program is like there is any program is running inside the board, and step is A to Z, and now present step is it's in the like M. Now you want to restart it from the beginning, then you can reset it. It will not like delete your program, it just reset it. So this is all the architecture of it. And now we will move on the some programming language. For it we generally use embedded C, and there is some predefined syntax. First we will look on it, then after we will download the software and install it and start to program the embedded things like LED, motor, sensor, how to interface the LED, how to blink the LED by the program, like how to run the motors. DC motor will work today. And then after we will use the IS sensor, and we will read that value. IS sensors generally used for detect the presence of any object. If there is a like any object in front of sensor, it will detect it and give the particular value. So these things. So now let's start. Okay, are you getting my this screen? Are you getting this screen? Here is one Arduino. So some basics. Now let's start look on the some basics syntax of it. Like Arduino IDE, this programming language use is not we are going to develop some software. We are going to program our embedded system. So here is some predefined syntax like digital write, analog write, digital read, analog read, and pin mode. Suppose that I have one LED like this one. Wait. If I talk about the specification of it, the Arduino, it's 8 mega 328 and it's work on the 5 voltage, and it's have 6 PWM pins, 6 analog pins, DC motor current is 20 milliampere, and its flash memory is 32 KB, SRAM 2 KB, EEPROM 1 KB. It's all the like clock speed is 16 megahertz. On LED button, there is on the digital pin number 13, there is an inbuilt LED, and its length, width. So it's all the specification of it. And if I talk about the programming, like this is the basic structure of this particular programming for the Arduino programming: void setup and the void loop. First, understand what is the void setup and the void loop. Void setup and the void loop. If you start the program, you will get this particular window. This window. There will be the void setup and the void loop you will get. Like here is what is the void setup and the void loop. If I talk about the architecture of this particular program, in the void setup, we set up the all that things, whatever we are going to use in the program or in the software. Like I want to blink my LED. I have a one LED and I want to blink it or glow it. Like here, this is my Arduino, and here this one is LED. Now here you can see this is LED. LED have a two terminal. One terminal is positive and second terminal is negative. In LED, two terminals. One is long leg and second one is short leg. The short leg is a negative and long leg is a work as a positive. Then I will attach the positive part of the LED with particular resistor, and then I will attach it by use of cable or a wire with any digital pins. And negative I also attach with any particular digital pins. first thing, what is the LED, light emitting diode, and what is the resistor? Resistor is used for limit the current. Like suppose that in the my board voltage is, if your current is 5 ampere, something like that, just assume that. But my LED works only the particular 2 ampere or the 0.5 ampere, then I will use according to that resistor. Ohm's law V barabar IR. According to that, I will calculate it, and according to that, I will use the resistor. And it's not necessary to use resistor here. Without resistor, you can also do it. And by resistor, I will attach with positive part and the negative part of the LED. I will attach with any the two terminals of or the two different pins of digital. Two different pin of digital. And then now I'm going to program it. For the programming, like first void setup and the void loop is the fixed form. Void setup and the void loop is the fixed format. And then first I have to define that pin, because my microcontroller don't know anything. I have to tell this pins is used for the positive, this pins used as a negative. I have to tell each and everything. So like here in this thing we have to do in the void setup. And for define at, I will use pin mode command. Pin mode command is used for define that which pins work as a output and which pins work as the input. Output means we are giving the output, and input means we are receiving something. So I have to define that this pins work, because here 0 to 13 all the pins are input and output. So how my microcontroller know about this? This one is presenting, this one is using as we are using as the output and input. So I have to define each and everything. So pin mode, for that command we are using the pin mode 2 as the output. Now pin number 2 of the digital pin I am using as the output. Pin mode 3 as the output, means pin number 3 I'm using as the output. Actually what I want to do, I want to glow the LED. I want to glow the LED, and when it will be happen, when I will supply or when I will attach negative part of the LED with the negative of battery, or I will supply the power negative to the one terminal or positive to the other terminal, then my LED will be glow. So I have to program in that way. Like here, this is the done. I just define it, pin mode 2 as the output, pin mode 3 as the output, and then move that. In the void loop, digital write, digital, like here I want to give the output in the digital format, positive or negative. To fix, positive is known as the high or a 1, and negative known as a 0 or low. So here in the void loop, and I want to give the digital output, so that's why digital write 2 as a low means negative. I'm giving the negative to the pin number 2, and digital write 3 as a high means I'm giving the positive to the pin number 3, and pin number 3 attached with the positive terminals of the LED, and pin number 2 which where I am supplying the negative, which is attached with the negative part of the LED. Now LED is attached with the positive and negative, and now it will be glow. So here in that way we can program it. It's very easy. When we will do the practice, it will become very easy. Syntax is also very simple. Pin mode, for define the pin mode, that is input or output. Now I want to give the digital output. For that command is digital write. If you want to give the analog output, then command is analog write. So it's the very simple to use it. When we will do the practical, you will understand very well. Like now we will do this thing with the practical also. So this thing, now do you have any question regarding it presently? Are you getting my voice? If you have any doubt regarding that, if you have any question regarding it, just ask me. It's okay. So here and now, suppose that if I want to do some changes of it, now my LED is glowing. Now I want to blink it. So first, before the program, first understand the mechanism. If I want to glow, then when I will supply positive and negative to the both terminals of the LED, it will be glow. Now I want to blink. Blink means the LED will be glow, then off, on, then off, on and off. And when it will be happen, when I will supply the positive and negative to the other terminals, and then for the some duration I will stop it. Then after I will give the supply power, and then after I will stop it. Then it will be become blinking format. And how it will be happen, like in the same format, then digital write 2 low and digital write 3 high. In this time it will be glow. Then after I will put one command that is known as the delay. Delay means it will be stop the program on the particular time. Delay 1000 means for the 1 second, because it's work in the milliseconds. So delay 1000, and then after for stop the LED or off the LED, what I will do, I will supply the both terminal to the negative or positive. Like here, in this way we can do it. Here, all the program will be remain same, like too low as a high. Yani now in this time it will be glow. Delay the 1000 second. Yani after the 1 seconds, it will be stop that previous program and give this particular output. Digital write 3 as a low and 2 as a low. Now circuit will be break because both terminals are getting the low and low, negative and negative. Low means negative, high means positive. So here high LED is attached with the positive and negative, and here after the 1 second, both terminals getting the negative and negative. So now this time it will be off. How much? For 1 second. Then after it will be restart because it is in the void loop. So you can also give the output in the void setup, but it will be runs only the once time. But if you will put the all the mechanisms or the output inside of the void loop, then it will be continue because it's looping. The same program will be continue run. So you can also like give the all the mechanisms, all the output the inside of the void setup, but it will be runs only the once type. And the void in the void loop, it is in the form of looping, so it will be run time to time. So this thing we can like do is a very simple to use it. Now let's start from the Google. Just write down the download the Arduino IDE for the Windows, and you can download from here, and then you can install it also. Like here, you can go and you can download it. So here I already installed it. So now let's start with it. It's something slow, so that's why. Yeah, that is one. Oh, sorry. Okay. You can download from the Google's, and you can install it. It's very simple. There is no any process in the installation. Just click to the installation, and within the 1 minute it will be automatic install. Then after open it, like here. Okay, like when you will open this, the predefined the format of the void setup and the void loop. And in the void setup phase, like set up all that things whatever we are going to use in the program, and we put the all the mechanism in the inside of the void loop. So now let us start here. Now suppose that I want to like blink my LED which is attached on the pin. Suppose that 4 and 5 I already have a 2 terminals, so I just attach one terminal to the digital pin number 4 and second terminal to digital pin number 5. So first I will define it. So how to define it? The command is, and one most important thing, the Arduino IDE, this particular program is a case sensitive, means someone the P in small, M in the capital, so you have to write in this particular format because it's a case sensitive. Like here, this is one command, the pin mode, and now I use the two digital pins for glow the LED. Suppose that I use 4 and 5. Anyone you can use, like from 0 to the 13. So the for 4, then comma, then in the capital, and this means because I want to glow the LED, so I want to give the output. So this means my work as the output. So in the capital, output. Now the second pin, I'm using the 2 pins 4 and 5. So the same important thing here is one more command. That command actually in the Arduino for like for analyze our output, there is a one monitor, and for use that monitor, I just repeat this thing, my word, in the Arduino IDE software, for analyze our output, there is a facility of the monitor, and for use the monitor there is one command, and that command is serial dot begin. So I want to like analyze my output on the LCD. So that's why I am using serial dot begin. Then in the bracket 9600. 9600 serial dot begin. This is the one particular command. But what is the 9600? The 9600 is the baud rate. Baud rate means that data rate which is transferring from my Arduino to the LCD. Don't worry. During the practicals, we will like understand these things. I will tell you. Wait, just wait a minute. It's the baud rate, and then after like pin mode 4 as a output, 5 as a output, and cl dot begin 9600. 9600 is the baud rate. Cl dot begin is the command used for serial monitor. And now I want to like give the output. Which type of the output? Digital output. So that's why I'm using the command digital write. Digital write. D should be in the capitals and W in the D should be in the small and W should be in the capital. And now here like 4 because I want to give the output on the pin number 4, so that's why the 4. Then I want to give the positive means either you can use high or 1 also. You can also use the high at the place of 1 and 0 at the place of low. Digital write 5 as a 0. And then after, now I want to print the something message on the my serial monitor or the my LCD. So the command is for print the something value or message. The command is serial dot print. Serial dot print, and this is the format. Yes, this is the format, and here it should be in this form. Now here I want to print the some message. That's why I'm using in this. For the format is in this way. And now here put your message like here LED on, and I just here want to give the delay for 1000 means 1 second because it's work in the milliseconds, so that's why. And then after the 1 second I want to turn off my LED, and here I want to print the message after the 1 second LED off, and LED should be off at that time. So that's why I'm here the both making both the 0 and 0 means low and low. So that's why the current the circuit will be break and it will be LED will be turn off. And then after yes
you have given O instead of 0, I think.
Yeah, that's a fine because I want to turn off the LED.
Yeah, it should be 0, right? I think you have entered O.
Where?
Digital write 4.
Okay. Yes. Sorry. Yeah, it should be 0. Right. Then 0 and 0. Now my circuit will be break and my LED turn off. So this is the format. And then after, first attach the Arduino boards by the USB cable with the laptop. Then after, attach your Arduino boards with the laptop by using the USB, and then go to the tool. The first step after the write the program, attach your Arduino boards with your laptop, then go to tools and select your port. Like here the Arduino UNO is attached with the COM10, so select that particular COM port. And then after, first verify that. When you will verify that, it just verify it, whatever syntax you are using, that is the right or not. It's not like verify that your program is right or not. It just verify that whatever syntax you are using, that is right or not. The board is also check the board. The board is the perfect. Is the Arduino UNO, and the COM port is also like right. And you can check your COM port is it right or not. I think there is something integral problem. I have to check my installation, and the installation of my software. There is something problem because like there is no any error in this particular. You are also doing the practicals, guys. Is it Mr. Anil?
No, Shish, because I don't have any board circuit board or anything.
Okay, fine. Let me check once more. Then what is the problem? Arduino and if you have been user. I think there is something installation problem. Otherwise, the program is is the right and perfect, and it's should be work. There is no any error in this particular program. For upload your program, for verify it, just click here, and for upload the inside of like a microcontroller or Arduino board, click here. Let's check here. It's uploading. It's done uploading. It's the perfect right program. And just give me the 1 minute. I will show you that all the with practicals. I just going to attach the camera with it, and then you can see the output also here. Just give me the 1 minute. Yeah. Hello everyone. Now you can see here. Are you getting this screen?
Yes, Ashish.
Yeah. Here you can see this is the my Arduino board, and this is the all the digital pins here to here, 0 to 13.
Okay.
And I just this is the one LED, and here you can see like this LED have
Okay.
one two terminals, one positive and one long terminals, and second one short terminal. The long terminals work as a positive, and short terminals, short lag is known as the negative part. And then I will just attach in that particular format. And this one is the breadboard. And now here you can see it's blinking now. And here I attach by using this particular jumper wire on the pin number 4 and pin number 5 of the digital. And now it's blinking because here I did the program of the blinking LED. And now one more thing, here I also use the LCD, monitor ports serial.begin 9600. So go to tools and open the serial monitor here. So you will get the same message like LED off here, like it's not readable. Then here you can select the same baud rate 9600, and this is the type of the LCD, no line ending. Now here you can see LED on, LED off after the every 1 second. This is the print. Is the facility in the Arduino IDE. There is you will get a one particular monitor where you can analyze your data, analyze your output also. And like one more interesting thing here. Now every message in the raw format, coming in the raw format. Like here the one more command. Here I use serial.print. If you use serial.println command, means every message will be print in the new line, like here the stage ln, and then after upload it, and the first program will be automatic delete. Now it's done. Now go to tool and open the serial monitor. Now here you can see the every program, every message is coming in the new line, because here we are using serial.print ln. Ln means new line, and there's a
Ashish,
yeah, yeah.
how after uploading the program, how do we need to run that one?
What?
To close after uploading our program to the microcontroller,
Microcontroller. Yes, yes.
how can we run the program? Is there any we need to start it from here, or
No, no, no.
after
First,
uploading
write.
directly?
There's a two-step. Only the two-step. First, write the program. Then
Yeah.
from here, verify it. Okay.
Okay.
Then after the verify, here click here. It upload the program. Then it will be automatic go to inside of the microcontroller. And when you will supply the power, because here I'm giving the power by my
Yeah.
using the USB, it will automatic run.
Okay.
Because here is EEPROM. Automatic, it will be start to run.
Okay.
And here in the tools, in the serial monitor, you will get a serial monitor where you can we can analyze our output also.
Can you just show how you have connected the microcontroller to the laptop?
Yes, sure. Like here, this is the USB
Okay.
port cable,
Okay.
and one USB cable here,
Okay.
and the second USB cable here. You can see second port
Oh,
with the
okay.
Arduino.
Okay. So that will act as a power to the
Yeah.
Arduino.
Yes, yes. After the upload, this one I am using for the upload the my program the inside the microcontroller. After that,
Okay.
it's work as a power supply also. Or
Okay.
either you can like give the power supply from the battery or the from a 12-volt adapter also.
Okay.
And when we will upload the second program, the first program will be automatic delete.
Okay.
Like just like here, do with the discard this program. Only grow the LED. Now upload this program.
Why every time first time it is we are getting error when
Actually, there
upload?
is something I think installation problem. I have to like check it. Otherwise, like it's the perfect. It's a very simple installation, but it's a long time I use same the board. Maybe there is something integral problem, or the some otherwise there's some software.
Okay. And this program is Arduino embedded program or
It's the embedded C format, and
okay.
the some syntax is the like the predefined syntax. Okay,
Okay.
is the, by the company they develop this particular platform for especially for program the Arduino.
Okay. And suppose persons who are not familiar with embedded C, they can write in their own program and they can
Yeah,
run.
yeah, if you like the person know the other programming language like JavaScripts or any other like JavaScript, MATLAB, then you can also like program on that particular programming language and you can upload it, but you need a external programmer for that.
Okay. So do we cover all those things uh, in this course or?
Yeah, yeah, in the all the training, like here this one is not IoT. This one is like how to use the embedded board, how to
Okay.
interface the sensor and actuator. Because first we will interface the different sensor and actuator with the microcontroller. We will learn how to program and all things. Then after we will move on the second step. Like what is second step? Choose the particular wireless networking technology. Then after we'll move on the third step, use the particular IoT protocol, and
Okay.
then the step, share the data and control the things or analyze our data, or fifth step, analyze our data. This thing.
Okay.
So we are moving the step and stepwise.
And one more thing is here the pin 4 and 5, it acts as both input and output. It is taking input as digital high and digital low, and it is giving the output also.
Yeah.
But in the setup, void setup, we
No, no,
just
no.
defined.
No, like here is the both is the output, because here what we are doing here, like we want to glow the LED, and when it will be glow, when I will supply something power from my Arduino board, so I'm giving something,
Okay.
I'm giving the positive and negative, so that's why it's work as the output. Like
Okay.
in the second case, I want to like control the LED from the sensor. Then first I will take the value of I will receive the value of the sensor. The sensor will work as the input, and
Okay.
then according to that I will give by the condition, if else condition, I will make it in the program, and according to that I will give the power supply to the LED. Then LED work as a output.
Okay. And what hardware components I need to buy for
Okay.
this
Yeah.
IoT session?
Yeah, there is some Arduino board, some Raspberry Pi, and some sensor. I will forward the like will forward you like all the list of that by
Okay.
today.
Okay.
Yes. Now here you can see I just upload the LED glow the program. Now it's only the glowing. You can check the program.
Yeah.
Now, yeah, the same fundamental. Like now we will do with the DC motor, and then we will use the IR sensor and read that value, and then after we will control the LED from the value of the sensor. This thing today we will do. So this is the basic idea. I like we will do more, we'll do the practical with the more than 5 different type of the sensor, and the 2 different programming language we will use, like here embedded C, and for Raspberry Pi we will use Python, and then 2 different boards, 3 different board will work, like ESP8266, Arduino, and Raspberry Pi will work on the 3 board. And then also the 3 different IoT protocol and wireless networking technology. We will use 2 different wireless networking technology. First we will do with Wi-Fi and or modem, and then we will do also with GPRS. With GPRS model, we will also like do this thing, and then we will do our final projects. So like here, and now here, this is our DC motor. Like this is a DC motor. You're getting? Yeah. I want to just here.
Yes, yes, sir.
This is a DC motor, and it's have a 2 terminal. It's 2 terminal, and like in the same format, like I here I'm growing the LED. The same format I can also like program it, but it will be not run. My motor will not start to work, because LED works on the very low voltage, and for motor it's like needs something high voltage as a compared to the LED. For that we need a external module which work as an amplifier, but that is not amplifier, which work as the amplifier, which amplify the uh, output current, voltage output coming from the Arduino, and increase it and make it suitable to run for the motor. So like I will repeat my word, like here, this mode. This board is known as here the middle IC is L293D. L293D IC. This IC is also known as the motor driver IC. Motor driver IC means like it's used for like coming voltage from the Arduino. Like whatever we just programmed our Arduino board for run the motor, same as the LED. Then after the voltage coming from Arduino board is very less for run the our motor. If we will directly attach our motor with Arduino board, then we will use one particular motor driver board. This board, what it will do, it will just take input whatever voltage coming from the Arduino and increase it or make it suitable for run the DC motor. So in this module, here is output. This one is the output port and this one is the input port. In one board, we can run the two motor. So that's why this is the for one motor output and this one for input this one. For second motor, the output is this one and input is this one. And here is middle is some power supply means VCC ground for start to work their IC. This is some power supply port and we have to attach VCC to the 5 or ground to the ground. So like how we will do like here we are going to use the one motor, so that's why we will use only the one port means suppose that you can use this one or either this one, it's depend on you. Like for this output input is this one, remember it. For this output input is this one and for this output input is this one and this is the power supply means some of that is you can see here like some of that here I think it's not visible like but here is and these three pins the two pins is VCC and middle pin is the ground and side of that two pins is VCC. VCC means positive and middle means negative. So I will directly attach VCC to the board of the my Arduino with 5 voltage and the ground to the ground of my Arduino board. And I will attach the input part to the Arduino because the input part to the Arduino and output part to the motor. Here this one is the output, then I will attach this port to the my DC motor and this one is input and I will attach this thing to the my Arduino board because input it will receive something from the board, the voltage, low voltage. It will get the low voltage from the Arduino and make it suitable, increase that voltage, amplify it and make it suitable for run the motor and give the output on their output port. And their output port is this one and I will attach here the DC motor or the BO motor. So my motor will start to work. So now first let's do the all the program. Then after we'll attach this thing here in the same format. Now let's use the 4 and 5 the same and here like the same program will be work because what I want to do, I want to just run my motor and for that I have to attach or I have to give the one like a port of the DC motor with the positive and second port to the negative and it will be start to work. So same thing I will do by use the program. So the same manner like LED glow it will be work. So now let's first upload this program. It's already inside of that. So now like just start to attach all things in this form. We can like I just attach a DC motor with my module DC motor driver. This module is known as the motor driver in the same format. And then after like for this output, the input is this one, and I will attach this input port with my Arduino pin number 4 and pin number 5 because I program on the pin number 4 and 5. You can use any other pin also, but you have to attach on that way. Now here by use of the some jumper cable, like this is some jumper wire, and here and this is my board, and I will attach with the pin number 4 and pin number 5. Okay, now it's done. Now I will like attach the power. I will give the power supply. So in the both this one, this terminal, and the both opposite terminals, side corner is the positive and middle one is negative. So negative I will attach the negative means ground, and positive terminal I will attach with the positive means VCC. So here this one is the like a positive. So I will attach with the positive.
Avinash,
With my
I'm not able to see the power connections.
okay, let me just wait. This one is the positive, like this one. So here, as we know that the side of the analog input pins, yani this one pin is the power pin, and here is some VCC, some ground, some power pins. So I will attach according to that positive to the positive, like here, this one the positive. So I will attach according to that with the positive, and then like this one is the ground portion, middle of that, and this one is the positive. Yeah, this one is the positive. Yeah, this one is the positive, and this one the ground. Like, and this one is the positive. So here I will attach. This one is also work as the positive here. Just attach in this way. Like what I did, I just attach positive to the positive and negative to the negative. I just attach positive to the positive and negative to negative, and the program is already the inside of that. And here you can see the motor is working. I will show you like here. Uh, I have also like in the end of the course, I will also like give some study material like that, and here you can see. Actually, there is something in the last. Let me check. There is also all the circuit diagram also, and you will get the idea how to attach. I think it's not here. Like okay, just leave it. The very simple. Like just attach the positive to the positive and negative to the negative, and the motor driver. And like, wait a minute. I think there is something circuit issue. Okay, now fine. Now here you can see it's rotating. And here is like a message is LED on, so you will get the LED on message on the like on the serial monitor, and it's very fast because it's in the looping. Just make sure that whatever baud rate you selected, just make it here. Like here is different baud rate. So in the program I use 9600. So first select 9600, and in the 90% cases the type of the screen, this is the type of screen, the no line ending. The sum of, in the some case, we have to use the both analog and CR. I will tell you when. And in the 99% cases we use both analog, sorry, no line ending. So are you getting this thing? Any doubt?
No, no, Ashish.
Okay.
And Ashish, a person who chooses IoT as a profession, do he needs to work on all this hardware part, or how it will be on the real time work?
Like what now? Uh,
Suppose if someone chooses IoT as a profession, so he needs to work on this all this hardware part and along with the software, or
no, there is a different domain in the IoT. But uh, before like move in the IoT part, we should have a knowledge about the
okay,
hardware also, because
okay,
where we will implement it, we'll
okay,
implement on the hardware, no?
yeah,
So we should, at least the basic idea is what is the hardware. It's
okay,
not necessary to we have to work on the hardware. There's a lots of domain like data analysis and like in the IoT programmer, and the further
okay,
different programming language, Ruby and this one Python, JavaScript. So
okay,
like there's only for that you should have a basic knowledge about hardware, because where we are going to implement it with the same hardware. So
okay,
how it's working, if you have the basic knowledge, so it will be good.
okay,
And this is not hard. When we will do the once time with the practicals, no, it will be very easy to like every new person who don't know aware about this hardware, like if they will do the once time with the practicals, it will very easy. And of course the in the first form or the first we are not learns all that things. When we will implement by self, then we can like beat in all that things. Okay, now this thing. And now let's start some one more interesting things, how to like read the analogs, how to read value, sensor value. So now let's start to do the practicals. And now I have some sensor like here, like here you can see this is the IR sensor. IR sensor I have, like here the simple For use the serial monitor, the command is serial.begin, and for printing, serial.print, and for read the input, serial.read. We'll do the practical term. Like this is the IR sensor, and this is also known as the proximity sensor. This is the IR sensor. It's also known as the proximity sensor. If I talk about this board, here is like three pins: VCC, ground, output. VCC means positive, ground means negative, and output means output. In this particular pins, this sensor gives the output. And what is the mean of how we can define the sensor? Sensor is electronics board or electronics hardware which sense its change its surrounding, which sense change its surrounding and give the corresponding value. This is the we can simple term we can define the sensor. And the proximity sensor is generally used for detect the presence of any object. Detect the presence of any object. If there is any object, so it's give the something value. If there is a no object, so it give the something different value. And here, this is the variable register. First thing, what is the register? Register is used for limit the current, decrease or increase the current. And variable register means there's a two type of the register. One is the fixed register, which value is the fixed, like either 100 ohms, 200 ohms. Ohms is the unit of measure the resistor, or like 1 kilo ohm, 2 kilo ohm, either the fixed value. And second is variable register, like this one is the 10k ohms, 10k v ohms. Yani this one is the variable resistor. This value is 10 kilo ohms. Means, and you can vary it something less or increase nearby the 10k. This is the variable resistor. And here, like this one is the LED, and this one is IC used for it, LM358, LM358 OPAM IC. And this is the two diodes. One is photodiode TX and photodiode RX. One is transmit the IR rays, and second one is receive the IR rays. And this same format you will get in your TV remotes. In the TV, there is a one same diode, and in your remotes there is just one same diode, and you will like get it. And one is transmit the IR rays, second one will capture that IR rays, and according to that it's work. You can see one TX and one RX. So one TX LED is work here is in LED, at the place of LED, and the IR module or in the proximity sensor there is a IR transmitter which transmit the IR rays, infrared rays. And suppose that there is any object in front of the sensor, it will be reflect and captured by the photodiode RX part, and according to that it will be it's give us some corresponding value. If there is a no object, so it will be direct there is a like the photodiodes did not capture anything, or so it's according to that it's give the something other value. And like we can read that value in the analog or the digital format also. Now let's do with the practical. So like here the two things. First, I'm going to like how to read the digital value of the sensor. Like here I want to read the digital value, then I want to read that. So that's why now it's work as the input. Now it's work something like input, because our Arduino board something receiving, want to receive something. So now it's work as the input, and now I want to read the digital value, then I will use digital input port. I will attach this thing with the digital input port. Suppose that if you want to read if you want to receive, or if you want to digital read the input value, read the something digital value, then you have to use digital input. If you want to read the something analog value, then you have to go with the analog input pins. If you want to give the analog output sorry, if you want to give the output in the digital format, then you have to use digital output pins. If you want to give the analog output, then you have to use analog output pins. But here is analog output pins is in our boards there is no analog output pins, so we can use PWM pins, pulse width modulation, for give the analog output. That is the PWM pins, that is a digital input or output also, but that pins also work as a analog output pins. So we will do that things with the practical. We will control the motor speed, or like LED intensity will do that things. So now here, let's start with the read the digital value. For that, I will use digital input pins. First, let's move on the programming part. So here, only the one pin mode I will use, because there is in our sensor there is a three pins: VCC, ground, and output. And I will attach the output pins with the one particular digital input pins. So I will use pin number 4 as an input, and then after share command, and after here, like so first thing, what is my mechanism? My mechanism is I will create a design, or create or design one particular container which can store the integer data, because the whatever the value coming from the sensor is integer. So I will create one particular integer container. If that is the something decimal format, then I will take float. So here in the starting, create a in the small integer, like name of the container. You can give the anything, like here I'm giving, like you can give the any name, like here. Then here the sensor equals to, and for command is for read the digital value, the command is digital read. And I want to read the digital value from where? From pin number 4. So here pin number 4. Suppose that if you are using pin number 5 or the 10, then make it pin number 5 or 10 according to that. And now just I read it and store it in the container, and name of the container is a sensor. Then I want to print that value on the serial monitor, because I want to analyze that value, I want to see that value. So the command is serial print ln. So like every value will come in the new line, so that's why I'm using here. What should we print? Value. So here make it value, and then close it. Then after, put the delay, because after the one value, one output, the second value will become after this 1 second. Sorry. Here make it sensor. First, sensor equals to, what is the sensor? Sensor is a container which can store the integer data. Here in starting, I already defined it. int for integer sensor. Then after, sensor equals to digital read the digital value from the sensor, from the pin number 4, and store it into the container. The name of container is sensor. Then serial dot print means print the, what the print? The sensor. And what is the inside of the sensor is the value. And here I will give the delay. So the difference between the two value is 1 second. After the 1 second, second value will be print. And now it's done. And then upload it. Okay, just wait a minute. Let me check what's the issue. Actually, what I hear is something installation issue I'm getting. So here is something error is coming. Like I will install it by today, and it's something installation issue. Otherwise, the program is a perfect. When we will run this thing and attach with the sensor, you will we will get the output on the serial monitor. Today, what I did, how like how to read the sensor value, LED blinking, and DC motor. And for read the digital value, the command is digital read. Like if you want to read the analog value, the command is analog read. And by using the different commands, we can uh, read that value of the sensor. And then after put the some if else command, we can control the any device from the value of the sensor. Like in the all the system, first we will learn how to use the hardware, how to program it, how to program the embedded things, because here we are going to work totally on the embedded system. So how to program the embedded system, how to use that things. Then after, first we will learn this thing, how to interface the different sensor, how to interface the LED, different actuator, different sensor, different module, how to program it. Then after, we will move on the second part to use the wireless technology and IoT protocols. That will be much more interesting part. And like here, these things. So so I think it's done for the today part. Today, I think the Arduino software is not working. So for tomorrow, we will move further parts. So if you have any doubt regarding it, you can ask. You can have each and every single problem doubts if you have. You can ask me.
Okay.
Okay,
Ashish,
like
that
yes,
is fine. Actually, I've asked Naresh IT that is it possible to change the timings to 8 o'clock IST and
yes,
1 hour
yes.
session?
Okay, okay. Yes, yes. From the like tomorrow we will go with the 8 o'clock.
And
Like
can it be a 1 hour session daily?
1 hour.
Yeah.
Mm. Okay, okay, fine. 1 hour per day. Like I will talk with the ma'am, and then they will contact with you. The team will be
Okay.
contact with you.
Okay.
Okay.
Okay. Okay.
Okay. And
And
any
also,
like
can you please
yes.
share what are the hardware devices
Yes,
I
sure, sure,
require
sure,
during
sure.
this course so that I can try searching for them?
Hmm. Sure, sure,
And
sure. We will forward
what
you.
softwares I need to install apart from this Arduino?
Arduino IDE and the Python.
Okay.
Python 2.7. In the like in the list, I will mention the
Okay.
software requires software and hardware,
Okay.
and you can like download it and you can
Okay.
thing,
Okay.
do this thing.
Even when we go to IoT concepts like wireless and other things,
Hmm.
do I need to require any other softwares to install or only Python
Only
will do?
Pythons will do everything we can do by Python. So
Okay.
more and more we will work on the Python. This is only this for the starting. Then after
And
we will work more and more on the Python.
okay, and you'll share the documents for this embedded coding
Like
and
yeah,
hardware
yeah.
connections,
Yeah,
everything, right?
this thing I will say, but after the end of course, this is about the protocol. After the end of course, we will say, give
Yeah.
the one particular study material. There
Okay.
is each and every single thing about the all the content, like
Okay.
circuit designing, programming, and each and everything. Okay,
Including hardware part.
diagram also part also.
Okay. Okay.
Like this is in that format. You can see here. Here is
Yeah.
all the
Yeah.
hardware and the component and the programming connections.
Okay.
All each and everything you will get there.
Okay.
Hmm. Or any doubt regarding it, any questions like do you have, you can ask me.
Uh, Today, I think it's clear as of now.
Okay, okay, fine. Okay,
Okay.
okay, see you tomorrow.